Hello and welcome back. This time we'll be working on our bulls and cows game. We're going to make it to where it actually loads the words list from a file if we give it a file. Otherwise it'll load this default words list. That's not very much fun since it's only got 5 words in it. Now to do that, we're actually going to use command line flags so that we can flag the executable, flag the game to let it know this is the file that I want you to load the words from. And we're also going to be having that file be formatted in JSON format so that we can start getting used to loading and unloading JSON objects. So let's get started. I wanted to start off by introducing you to a really awesome website. Now the default Go website is awesome, and it has tons of examples and tons of things that you can find there. But Go by Example is actually a really cool website as well, and it has all of these examples laid out for you right there, so you can just like read down and see what if there's anything that you're wanting to do or learn how to do, or something that you're curious about, like say you're curious about defer that we'll get into later, etc., etc. You can look in here. So for instance, command line flags right there. So, we could go off of this if we wanted to, but I'm just going to get into it and do it. So first of all, we're using the flag package, right? And we're going to want to load in our path into a global variable called path. It's a string, of course. And we're going to do all of this flagness inside of the init function. So first we're going to say flag, and we're going to load a string variable, and we're going to point it using a reference at our path up there, and we're going to give it the name of the flag, which is to say what you actually type into the command line. So -f in this case would, and then you set that equal to what you want the path to be equal to, and then we're going to give it a default value. Now notice we are giving it a default value. That means that this variable path will always be set to something. It's never going to be nil. It's never going to be null. It's and it's always going to have something in it. So that's something that we're going to have to bear in mind here in a second when we're trying to determine whether it's actually been set or not. And then finally, we give it a description as to what this is doing. The path to the JSON file containing our word list. Right? So that means that when we do dash, one of the great things about this flag package is it not only will handle reading and then parsing, which is the next step. Whoop, parse, not parsed. It will not only it handles not only the setting up of these flags, but it also will then and also handling all of the reading of the arguments into the command line and filtering it through these flags and thus taking care of the flags and setting them to the appropriate variables, etc., etc. It also has a built-in help, and that's where this description comes in. So you can do --help or -h, and that will give you the list of all of the flags that you've set up for this executable, and you're good to go. So that's our flags. That's us getting our path in. Simple as that, right? So now, in order to tell if we have loaded a path or passed a path in, or it's got the default value in it, we don't want to check if it's equal to that, because if they actually set it and set it equal to that, well, that's what we want. If they just so happen to send in .words.json, that's what we want. So what we actually have to check is a function that comes with the flag package called inFlag. And actually, let me double check this real quick. Keep hitting that. And what it will do is it will actually give us inFlag. Yep. it will give us the number of flags. That is to say, flags, not arguments, that we have passed in. And so we're wanting to check if there's no flags that we passed in, then we want to do the default thing. Now, that also means that we need to take this word out of here. So we can't allocate it in here and then use it out here because of what's called scope. So whenever you allocate something inside of curly brackets, that is the scope of whatever you have allocated. So outside of here, you will get an error if you try and use the word. In fact, you know what? Let's go ahead and see that. I'm just gonna print the path up here just so that you see that it is that, in fact, that default value. And then we're gonna load up our shell, go run. We are gonna get an error. That's fine. We expect to see an error because we're doing flags with run. And whenever you do flags with run, you get errors if it actually compiled, but it can't even compile because the word is undefined, and that's what I was showing you. Because it's inside of the scope. So what we have to do is move it out of the scope. In order to do that, we have to create a variable called the word. And since we can't infer the type using the return here, we have to actually put string. So, and then we take away the allocate. Now, if we do that again, we get words as the default value. And oh, that's right. You get the error if you try and do the help. So notice it said error status 2. That's perfectly expected because it just doesn't like doing this inside of the context of the using run instead of build. So all good. If you do this, if you play with this and you want to look at the help, just know that exit status 2 perfectly expected in this situation because of the run. So don't worry, you didn't do anything wrong. You didn't break it, I promise. All right, so otherwise, if we did get a path, we want to load a file. So actually, let's talk a little bit about that, and let's go over here this by example, and let's look at reading files. So we've got a few things. What we really want to do is read this file, right? We want to check the error. Now check error is doing the kind of default error checking, making sure it's not nil, and then panicking if it is not nil, i.e. it has a value in it. I don't know that we've talked about that, but yeah. So whenever you're checking errors, you're checking that they're not nil. Now if they are nil, that means that there's no value. If they're not nil, then that means that there is a value. Okay? So that's where that comes from. I just can't remember if we've talked about that before or not. So actually, let's go ahead and let's do a the word is equal to read word from file. And we don't need to pass in the path because it's a global variable, so let's not worry about that. And actually, we're going to return both the word and an error. So let's go ahead and define an error named error. And since we can't do the auto allocate here, and then we'll check if error not equals nil, then print 9. Oh noes. File. And we're actually going to print in the other one the error, the actual error. But if that did load fine, then we're good to go past that point. So let's go down here. Let's go and define this function. Read word from file. And again, we're implying we're going to be using that global path, and we're returning a string and then potentially an error. And So let's just go ahead and make this work. And no, that's fine. So now this will work. Now this will compile. Now it'll run. Now we could theoretically. So let's actually play that. Right. So length of 3. It's Bob. Oh no, it's not. It's cat. All right. So, but if we do it with a file, and let's just do it that way, gave us an error because we didn't actually assign anything. So remember to actually assign something. So let's do word JSON, and it actually did load it. It would have loaded a file. There is a file there. Notice it's 0 length. If we just press enter, we win. But that's because all we're sending back from that function is an empty string. But we are not returning an error, so that's why it's actually working properly. So let's start loading a file from memory, or from the hard drive, excuse me. So first we're going to say file body and error. And we're going to allocate these, and we're going to use a package called IOUtils. Util. And all the way back down. And util. And read file. And then we give it the path, right? And so it's going to read that file. If it can read it, it will put the entire body inside body of the file into this file body, and if it can't, for some reason, it will give us an error. So we say if error not equal nil, then we want to return that error and an empty string. And oh, right, we said we were going to print that out. So let's go ahead and print that out. Print. Fine. Couldn't open /read file. And then we're going to give it the error to print out. All right. Next, we are going to, so in Go, there is a feature called map, okay? And it kind of works like, let me type this out and then I'll talk about it. It kind of works like an array, but instead of always having to use integers inside of the square brackets, you can actually define what you put into it to get out and then you can also define whatever type it's going to return back to you, right? So we're mapping strings to what's called an interface. If we go back over here and go to, so we've already loaded the file at this point. Now what we're about to do is actually parse what's called parsing the JSON. Just making sure that it's supposed to have those curly brackets. And so this is the rough way of loading JSON. So what we're going to do is this can potentially return an error. So we're going to be using a package from the I can show you over here real quick. From the encoding package, it's a sub package inside of encoding called JSON. Okay. We're also going to be using. No, we're not. So encoding /JSON. Now we can say JSON dot unmarshal, which is to say parse. I always put an SCN7S there. but then we give it the actual string that, or basically string that we want it to unmarshal, and then we give it a reference to what we want it to unmarshal into. Okay, so then we check if there's an error, of course. If it doesn't equal nil, then we want to say, we want to print out something intelligent, say couldn't parse file, and get the error, and return empty string with the error, and then we're good to go. So now we theoretically have stuff inside of our map up there. Okay. Let's see if surely they talk about maps. So here we have maps. So this will let us. This will show you a little bit more about maps. I was hoping it would show. Okay, yeah. So what you can do is if you pull something out of it, then into just a single value, then it will give you the value. It'll give you whatever is stored there. If you do it into two values, I don't remember what it's doing here. Optional second return value when getting a value from the map if the key is present. Oh, yes, exactly. So it's a Boolean value. The first thing would be the value, and the second thing would be whether it was okay or not, whether it actually found something or not. And that's exactly what I was looking for. So what we want to do is we're going to do a really cool if statement where we get the value word and words, because we're trying to get the list of words, and okay to let us know if it's actually okay, if it's actually present or not. Okay, and we're going to get that from the raw map, and I already created a file for this. So let's look at the format real quick. So you notice it's actually got a key of words, and then that key gives you an array of words, right? So we're going to try and pull that words key from this raw map. So just like we would have done with an integer, but we're using strings, right? And that's all right. So then we do a semicolon, and then we say okay. So this is where the actual conditional of the if statement is, and what we're saying is if it is okay, then we do whatever's in here. Else, we'll print out print line could invalid JSON data, right? And we'll leave it at that, and we'll return an empty string, and we'll do format error if, and this just lets us create an error really quickly, and we'll say invalid JSON data. Okay. All right. So now what happens if we actually get the words? Okay. If we actually get the words, then this words variable should have essentially the same thing as the, we can't use that because we're already using it here. So we'll say temp words. So it'll work exactly the same as that other variable, except that we've loaded it from this file. Okay. So in that case, we want to go up here and do basically the exact same thing that we did with the other one with the random, right? So we want to copy this, go back down. We're going to have to change things a little bit because we're using temp words instead of words, right? and temp words instead of words. But that should do it. Oh, excuse me. No, that shouldn't do it. We need to return that, right? And then we also need to return a nil for the error. Now that should do it. So let's give it a go. Oh, excuse me. And we want the shell. All right. So if we use this again, okay. Cannot find package. Oh, okay. So what happened here is I was wrong about where that package actually exists. You don't get to this directly. You actually have to go through the IO package to get to that, right? So let's try this again. Alrighty. Oh, okay. Right. So we are bringing in, you notice this is a map of strings to interfaces. Now what interface is it's kind of like the generic type of Go. But that's not what we want. What we want is actually a string of arrays, or a slice of arrays, excuse me. A slice of strings. There we go. And so this will not work. So what we need to do here, actually, what we can do here is what's called casting, since we know what it's supposed to be, and hopefully the OK will catch if this isn't right as well, but we're going to give it a shot anyways. We're going to do a slice of strings and see if that fixes it. Yeah, let's see if that fixes it. Yeah, nope. Invalid data. Alrighty. So we are going to grab this let's look at this again. Okay, so if you notice here in this example, we can shift it to an array of interfaces, and then when we actually grab it, shift it to a string. So let's do that. So it's an array, or a slice of interfaces, and don't forget those curly brackets, and then this will give us our array, and then when we actually access it, we convert it to a string when we're sending it out. All right. We're going to do something different here in a second. That's going to make that so much better. All right. 5 letters. If you were quick on the ball and in reading that file before, you'll know that it's probably Peter. Yep. All right. Okay. So this use of JSON is obviously very cumbersome. All these castings, and it's unsafe, and it's just really kind of not cool. So what we're going to do instead is we're going to use what's called a structure. Now, this is a new concept that we haven't talked about before. Go does not actually, it doesn't really have the concept of objects. Instead, what it has is structures, and then you can have interfaces on those structures. Which an interface is more or less like a protocol. We'll get more into that later. But for right now, just know that a structure contains data. It's basically creating your own type. And so we're going to create one of those real quick. Now, one really cool thing is that you can actually create what you would call a temporary type or a temporary structure. by doing it inside of a scope. So instead of doing this at the global scope, we don't need it for global scope. We just need it in here in this one function. This is the only place we need it. So let's just make it here. Let's not pollute our global scope with the structure. Okay, so we're going to make a word list structure struct. Okay, and inside of it, it's going to have our words, and we need to make so very important with structures. If you want to be able to access one of the pieces of data inside of it, you need to make sure to uppercase it. That is the way that Go determines whether something is public or private. Private variables cannot be accessed from outside of one of the interfaces for that structure. But basically, it's not accessible to the public. Okay, so we're going to say words, and it's a slice of strings, right? Now, inside of structures, you can have on these variables, you can have what are called tags, and they're denoted by this this tick mark. The key on the U.S. standard keyboard is the key right above the tab key. All right, it's the one that's the unshifted tilde on the U.S. standard keyboard. So you put two of those because it's actually containing the tag, and tags can be. There's a lot of different libraries that actually use these tags, but in this case we're using it for the JSON, right? So we'll say JSON : and then what we're actually going to do is tell it. So you know how we were using this words key, right? That's what we're going to put here. We're going to put words. So now, and actually we want this structure up above here because it's actually in the unmarshal that we want to use this, right? Now we have created our own structure, our own type, called word list. All it has in it is a slice of strings or an array of strings called words. And whenever the unmarshal sees the keyword words, when it is trying to unmarshal into this, it will actually automatically inject into it the data into this particular variable. Okay, so if we had more keys in there, then we would add more variables into the structure, and that's how we would get all of that data in. So let's go ahead and we'll still use raw, but instead of a map, we're going to do a word list. Whoop. List. And so nothing changes here, but down here, instead of doing any of that, we are going to we actually don't have to do any of this, because what will happen is if it tries to parse into this structure and it sees that the format is incompatible with this, it'll actually error out, right? I take that back. So one thing that could happen is we could check this raw, check its length, and if it was, and we're not checking the raw itself, we're checking the raw words. We're checking the length of that, and if it's greater than 0, then we know we have words in that file, right? And that's when we want to do this stuff, all right? And we also need to change this from temp words to raw words, raw.words. This is how you access something inside of the structure, is with the dot, much the same as you would from a package. Spoilers, that's basically what you're accessing with a package. So words, and we don't have to cast this to a string anymore, it's already a string. So that cleans up our code an awful lot. So let's go ahead and switch over here and just verify that it still works. And for, I'm going to guess Mary. Nope, okay. So I got one bool, so that's Paul then. Cool. All right, so now we've seen how to use flags. We've seen how to use JSON, both in the painful raw format. Now, this is painful. This using the raw map is painful, but it's really useful for if you aren't sure what the structure of the data that you're going to get back is, or if that structure of the JSON that you're going to get back is malleable. So for instance, if you're getting one, and we'll see this more in the next video, but if the structure is different for an error versus the successful return value, right? Things like that. That's when this sort of raw getting of the data is really super useful. But that's it for this one, you guys. I'll see you in the next one.